Lesson 1-4, Applications of Proportions. Our vocab for this lesson is all about geometric figures. So when we're talking about similarity or similar figures or similar shapes, the idea is they have the same shape, but they're different sizes. Okay, so these both have a 90-degree angle, and they are equilateral, so these angles are all the same, and so these two figures are similar. Okay, corresponding sides or angles are the sides that match up, right? Because we can have two similar figures that can be oriented or turned any way we want. We want to make sure that we know which angles and which sides match up. Okay, so these red angles right here, the obtuse angles, those are corresponding. This green side, the hypotenuse, these are corresponding sides, right? It becomes especially important when you're looking at shapes that are more complicated, because it can be easy to use the wrong sides and mess up your proportions. Okay, scale factor is basically the amount difference between the sizes of your similar figures. This is the multiplied amount, not subtracted amount. So the difference, the scale factor between these two is not 3 minus 1, it is 3 divided by 1. Okay, your scale factor from your new figure to your original. So if this is my original, and I'm scaling it down into my new figure here, I'm going to take my corresponding side of my original, that's going to be my denominator, and the corresponding side of my new figure, that'll be my numerator, and that's my scale factor. So in going from my original to my new, my scale factor is 1/3. If I had the smaller triangle as my original and the larger as my new one, I would have a scale factor of my original in the denominator and my new in the numerator, and it would be a scale factor of 3. So the rule is whenever you are enlarging, starting with an original that's smaller than your new figure, your scale factor is going to be greater than 1. Whenever you are shrinking, so your new figure is smaller than your original, your scale factor is going to be less than 1. Okay. Concept 1, finding missing measures in similar figures. So you'll often be given problems like this, where we have two similar shapes, and we've got one set of corresponding sides that we know the values of, and then we've got one missing value that we don't know, and one value that corresponds to that missing value. Okay. The way to solve this is by using a proportion. Okay, we're going to set up our proportion. That's our first step. And what we're going to attempt to do is have the variable as the numerator so that we save some steps later on. So we'll set up our proportion. And we have our smaller triangle. The ratio between this side to this side is 3:4. And that should be equal to, because they're similar, the ratio between this side and this side, which would be x over 10. All right. Now, because we have our variable here, instead of cross multiplying, we simply multiply this side by 10 and this side by 10, and then cancel that, and we have our answer. Our variable is isolated, and if we think about 3/4 as a decimal, that's going to be 0.75, and if we're multiplying it by 10, we're going to move that decimal over 1, and that gives us x equals 7.5. Okay. One other thing to note is that I set my proportion up as the two sides of my small triangle are equal to the two sides of my large triangle. And that is one way to do it. I could also set it up as the large triangle over the small triangle's corresponding side. So 10 over 4 is equal to my large triangle over my small triangle's corresponding side. Okay, and what I would end up doing with this one is the same thing. Multiply both sides by 3, cancel, and you can see I end up with 3 times 10 over 4, which is going to be the same as 10 times 3 over 4. I get the same answer either way I do the operation.